In this tutorial, we shall perform a general static analysis on a three-dimensional frame made up of I-beams. Aside from learning to use beam elements, you'll be introduced to important topics, such as the use of connectors as well as constraint equations to represent joints. Let's take a look at a model of the frame. The structure consists of two-dimensional frames which lie parallel to each other. They are connected to each other by horizontal beams at all of their nodes. I shall refer to these as the cross-bracing or cross members, even though they're not in the shape of a cross as the name usually implies. The structure is fixed at the bottom. All the beams on the lower side are constrained in such a way that they cannot translate in the X, Y, or Z direction. However, they are free to rotate. Line loads of 1500, 1000, and 500 newtons are applied as shown in the figure. We are going to use the dimensions from this schematic. We will use SI units, where length is in meters. The beams are made of steel with a density of 7,800 kilograms per meter cubed, a Young's modulus of 200 gigapascals, and a Poisson's ratio of 0.3. Our beams are I-beams. We will use different cross-sectional profiles for the beams in the frame and cross members. Note that the upper and lower flanges of the beams are not of the same length. The purpose of using such a profile in this tutorial is to demonstrate how to orient beams in Abaqus. When setting up the simulation in Abaqus, we will model the beam members using line segments, or more correctly wire features, just like we did in the truss analysis examples. We will then define beam profiles, create beam sections, and assign these profiles to them, and finally assign these beam sections to the wire features. The purpose of this tutorial is not only to work with beam elements, we're also going to introduce you to connectors. Connectors allow you to model a joint or a connection in Abaqus, and you'll see how this is done. In addition, we're going to introduce you to equation constraints by demonstrating how they can be used to create a joint. Here's how we'll set this up. The joints between the members of each frame are weld joints. We won't be specifically creating these because Abaqus assumes the joints between beam elements are weld joints. We will, however, need to define the joints between the frames and the cross-bracing. We will make these pin joints. We will use connectors to define most of them, and equation constraints for the rest. So you'll see how to accomplish the same task using both connectors and equation constraints. Also, in order to use the connectors and equation constraints, the cross-bracing will need to be created as a separate part from the frames. So the two frames will be created as one part and the cross-bracing as a second part. Beam elements will be used for the analysis. These elements are good for modeling structures in which one of the dimensions, specifically the length, is much greater than the other two. All beam elements in Abaqus allow deformation due to axial loads, bending, and torsion, hence these are ideal for the problem we are simulating. So start up Abaqus and let's do this.